Welcome to this strategic briefing on the life cycle of industrial threats. We will explore the anatomy of a modern cyber-physical attack, from the dark web to the factory floor. The front line of industrial security is no longer just the factory floor, it's the dark web. Attacks start with initial access brokers, who sell access to ransomware operators who then launch the attack on the target asset. Initial access is a booming, targeted business. 31% of targets for initial access brokers are in the United States, and 60.5% of listings target smaller companies. Compromised VPNs are surging, and prices range from $500 to $3,000. Thousands of industrial systems are directly exposed online, creating a vast hunting ground. This exposure of industrial control systems provides a supply for threat actors to find and exploit potential victims. The attack path often begins in corporate IT and pivots to the factory floor. In the German steel mill case study, initial compromise through spear phishing led to a pivot into the production network due to insufficient segregation. Attackers exploit the inherent trust of industrial protocols never designed for modern threats. Many protocols are insecure by design, lacking basic security. Attackers can insert a rogue server to intercept and manipulate data. Stuxnet converted a cyber intrusion into precise mechanical sabotage. The worm targeted variable frequency drives, manipulating rotor speeds to induce abnormal centrifugal stresses, accelerated fatigue, and ultimately, physical destruction. The Triton attack targeted the last line of defense, the safety instrumented system. The attacker's clear intent was to disable safety protections. Compromising the SIS poses an existential risk, leading to catastrophic mechanical failure and loss of life. Cyber-physical impacts create a spectrum of real-world disruption. Examples include environmental damage, as seen in Shire, mechanical damage, like the German steel mill incident, and economic disruption, such as the Colonial Pipeline ransomware attack. Cross-case analysis reveals a consistent pattern of security failures. These include poor network segmentation, a lack of process-aware anomaly detection, weak safety system hardening, and siloed incident response between IT, OT, and engineering teams. Forging resilience requires a defense-in-depth strategy across technology, process, and people. Key recommendations include strict network segmentation, integrated incident response playbooks, and deploying process-aware anomaly detection. The future of industrial security is human-centric. As AI and automation reshape the workplace, the most critical capability is a workforce that can bridge the cyber and physical domains. This involves new roles like cybersecurity analysts and human-AI interaction designers. To defend the physical world, we must integrate our understanding of the attacker, the system, and ourselves. Effective defense integrates knowledge of attacker methods, system vulnerabilities, and the unique human expertise needed to protect critical infrastructure.